Hello and good morning. This is the first day of the AI Tech Symposium, and I'm very excited to kick off the day with Ignas Mociunas. He's joining us from Switzerland, and he is a data and AI solutions manager. He has a ton of experience in the realms of data and AI across several industries. He's been hands on and actually started out in a startup. What was it that you were doing in a startup, Ignas?
We've been selling ML solutions for e-commerce in 2017. Total black box.
And where are you now?
Now I am in an EV charging company, actually selling 2 superchargers, and my role is here building up a data platform from scratch.
What it's a terrific to see how the journey has brought you here. So with that, I'm very excited to get a little bit of your knowledge with your presentation, and yeah, I'll leave you to it.
Cool, thank you. And first of all, good morning, friends from US. Good afternoon, everybody in Europe, and probably good evening in Asia. I'm pretty excited about the opportunity to kick off the AI Tech Symposium, sharing what I have learned across the year, and also listen to the sessions that are coming up. So much knowledge in the air. So in the next half an hour, I'll talk you through how to roll out GenAI in international supply chains industry, specifically in procure-to-pay process. If that's new to you, don't worry, I will provide some context so that you understand what's easy and what's hard about it. So the idea is to find the problem that's worth solving, see where GenAI could help, or maybe not, and also spend some time looking into workflow architecture. It's a tech symposium after all. So let's get going. Now, international supply chains. Here's what we would need to know about it. This is my take, how I have seen it from the last few years I got my hands on it. So when I think about international supply chains, how they differ from any other industries, the following things come to mind. Let's unpack 2. First one, legal entities. We are usually speaking about large networks of probably thousands of companies in various legal jurisdictions, geographical locations, working in many languages, and good, bad, or just different practices of doing business. Whether it's automotive, energy, construction, or maybe semiconductors, the complexity is always very high, and a lot of that is out of your direct control, unlike in some other industries. Another, I would say, unique feature of the industry that you can't see somewhere else to this extent is product configurations. If you're coming out from B2C world, you really have no idea. In many cases, components in supply chains have to be ordered from like 1,000-page catalogs. Unlike Amazon or Zalando, where you scroll some pictures, you like read 2-line description, and then you order and you have it next day. In supply chain, product variant differences are subtle and often can't be understood from images, or there could be no images at all. So you often have to talk to tech consultants before you can even order. So forget the self-service and forget the ordering on demand. These are very often not available. Now, procure-to-pay process. What is that one about? So a simple procure-to-pay process goes more or less like this. I would like to order some components for the rocket that I'm building. So first, what I have to do, I have to find some suppliers and ask them for proposals and get the quote. Quote usually includes some product configuration, quantity, delivery terms, and price. If that looks good so far, we place a purchasing order. Unlike B2C, orders are usually checked manually before confirmed. And there are many good reasons for it. Shipping is almost always very expensive. Manufacturing is often custom, meaning that there might be no way of reselling. And the order value might be extremely high, which makes delivery to a wrong address a big problem. If orders are confirmed to be available, packing lists help to make sure that components are not left behind, assembled and dispatched together with the other components as required. Once packing is ready to go, buyers get informed that orders are on the way. It could be by land, by air, or by water. And this might take from a few hours to a few weeks. Finally, once the buyer receives the shipment and the loading bay, they have to control that it's full, meets the specification, and then they sign the delivery note physically, which has to reach the supplier, and only then the supplier can generate the invoice. So not that simple and not that quick. However, there's a lot more complexity in the process. Often shipping internationally, we also have to have the certificates of origin that are assigned or generated not per product, not per shipment, but per product configuration levels. Bills of lading, if we are shipping something by sea, customs declarations for all the countries that shipment has to go through, depending on the route, some sanction assessments, partial shipments, and of course, handle guarantees and returns, which makes it pretty not that easy. And while in theory, the process should be left to right, in practice, we might have to do a few iterations. And this is where complexity evolves, skyrockets, and we're big companies, they have hundreds of people trying to chase up and unpack the models manually. Now, there's one more thing that when I describe the supply chain, I missed out intentionally. And I believe it's a crucial feature of the industry as of today. Adam, it's paper. Why paper, and what's so bad about it? So despite advanced process automations and millions spent on digital transformations, even in the top leading global supply chain companies, there is still more paper than digital documents flying around. That's important to know. Whether for legal, for compliance, for convenience, or sometimes just for old habits, it doesn't matter, but paper documents are everywhere. And let's look into an example why that could be a problem. Let's take Fortune 500 company, one of the market leaders, with large-scale operations in more than 200 countries, diverse product lines, offering anything from component manufacturing, transportation, energy, medical devices, and more. In their Procure-to-Pay process, every year, they still, despite the automation, still generate more than 5 million paper documents manually. That means 100,000 of new documents coming in every week, or 20,000 new documents coming in every day. That's a lot. And those are always incremental. It's not that the same documents that we have to process once and for good. And that's not it. Assuming each document has to be reviewed manually by, on average, 7 people, who have to check for 10 to 30 pieces of information to decide if to process it further. In my opinion, the estimate is very optimistic, but let's go with it. As the work is tedious, people get fatigued and tired, and the volume is just so massive, let's say 3 to 5% of decisions are mistakes that need to be looked and reviewed again. Where does that leave us? It leaves us with 35 million manual document reviews every year, 350 million decisions, and only 10.5 million mistakes. That looks like a big number, and this is in the Procure-to-Pay process alone. Now, I believe that's a problem that's worth solving. Now, next, given the problem is somewhat defined, let's move over to solution space and see if GenAI could be our silver bullet for some part of it. Maybe not, or maybe yes. What is GenAI good for? In Procure-to-Pay, I picked 5 main areas where technology could speed us up. I'm not going to talk about ChatGPT to write creative emails threatening your suppliers with like late payment penalties, though you could do that too. So the top AI skills that I see are summarizing, extraction, classification, a lot of the cases translation, and simple Q&A. Let's get some examples. Given we have plenty of paper documents flying around, often a lot more than we need. If per ticket or per case, per supplier, we have hundreds of pages to look through, it becomes increasingly difficult to filter out the noise, especially if you don't have the modern tools available. In the first example, let's say I'm a logistics manager who got forwarded an email saying, please sign. There's no more text, there's an attachment, and inside there seems to be an updated version of some supplier master agreement changes. Document is 140 pages long, changes unhighlighted, and of course, there's no reference to the previous master agreement for me to compare it to. To make it harder, we could also say that the document I received is a document scan, meaning image, which means I cannot do keyword search on it, and the only way for me to figure it out is to read it through. In such case, adequate GenAI models connected to internal knowledge databases could provide you summary with only changes relevant to logistics, saving you hours, if not days, by ignoring all the other noise that is relevant to the other divisions, however, not to you. In a different example, you might also have a master's agreement for shipping insurance. Again, 100 pages document, but this time you only care about the geographical coverage and sanction clauses to make sure you're not crossing the lines you're not supposed to, and you don't care about everything else. GenAI could point you to the right paragraphs within a few seconds, so you don't even need to open, read, scroll, and scratch your head trying to figure out what is really that you need, and is that even mentioned or not? You never know. So there's one more dimension to consider. In Procure-to-Pay, similar like in the other processes, we have some frequent and some rare cases that we need to handle. In the graph on the right, green means most common cases, or documents such as invoices of monthly billing, or computer-generated human-oriented PDFs that are easy for a person to read and to understand. There is usually a robust process to handle those things quickly, and there's already some process automation in place based on some rules. In the tail end, we would have requests taking much longer, either new suppliers coming with new templates, documents in exotic languages with non-Latin characters, or master agreements that require entire your legal department to review before you can proceed. Somewhere in the middle, we might have machine-oriented PDFs, for example, prints full of barcodes that are quick to process with the scanner. However, it tells you nothing if you're looking at it with a human eye. So depending on the use case, there are loads of AI tools available. What could that be? For high-frequency processing, we're looking into RPA, which stands for Robotic Process Automation. The term is not new at all. Companies have been on it for years, usually by writing complex sets of business rules and logics to speed things up. Now, the issue with existing logic is that it is distributed. It's not well organized. It goes out of date the moment you publish it. It is difficult to maintain, and it is difficult to find, and it is not flexible, meaning it breaks whenever anything upstream or downstream changes, and nobody gets informed usually. Here, the GenAI could indeed be a silver bullet to an extent. AI skills, which are probabilistic, could be covering majority of the volume where the confidence is high. What does that mean? It means there's little doubt or uncertainty about the data accuracy, validity, quality, and the next best action. What should happen with this information? Where that's not the case, for example, where a crucial document is missing or seems like a duplicate that could have been processed already, such requests get forwarded to human in the loop as exceptions. So this buys us a lot of processing speed and accuracy. In a different case, on the tail end, we could use document AI to ask questions about the documents and files that we get. Is this a purchase order? Is the shipping address the same as the invoice address? Is there a signature on delivery note so that we can issue an invoice? There are very good out-of-the-box tools for that in many cloud ecosystems, and they can help you to profile and route such requests a lot faster. So those are a few of the ideas. Now, so far we covered the problem. We got some ideas where GenAI tech could help us with the Procure-to-Pay. Now, the big question is, how do we actually go about implementing in practice? So here you can see some sort of maturity roadmap. And today I'll only focus on the step in the middle, proof of concepts. Now, what is a proof of concept? And let's say, like, what is the goal? When delivering proof of concept, we have to ideally reach three things. First of all, prove the technical feasibility, that the tech at the back actually works, that we can actually extract or classify reliably. The look and feel has to be good enough. And we also use proof of concepts to validate our assumptions about the value that we could deliver. Especially in early stages, a lot of promising tools and solutions are sold as silver bullets that they say look like it would speed you up 100x. In reality, we probably don't believe it, but if we reach 14x, that could be already good enough. So this is something that, within the POC, we try to understand what could be the real value we could get when implementing it. Now, finally, we have some time. Comes the good part, and I hope we'll have enough time to cover it. When preparing POC, the single most important thing is to pick the right use case and lock in realistic scope. Now, how do you do that? You need, first of all, a sparring partner on your implementation side, meaning a pioneering client or business sponsor who has interest to push the use case forward, to sell your idea inside their organization. And on the other side, you need to have enough data to work with. Those both two are deal breakers if you don't have it. There will be additional hurdles like filling in InfoSec surveys, questionnaires that could take days, could take weeks, could take months, but you can get through that. I often get asked, how long does it actually take to deliver a proof of concept? While the consulting answer is often it depends, I will give you my real answer. So in my experience, it might take to be between 1 to 3 months of preparation and alignment. However, the tech implementation itself and delivery could be as quick as 2, maybe 3 weeks max. What takes a lot longer than development is actually booking a meeting with all the internal stakeholders to demo the result that it works. It's a bit unfortunate, it's a bit sad, but that's how it works. And so the important takeaway here is probably that tech development and delivery for the proof of concept can be done really quickly. It doesn't have to be a bottleneck. It usually is a lot quicker than getting the alignment and putting something into people's calendars. Now, let's assume the use case is clear. Let's also assume we have enough data. We have reasonable ideas for value benchmark, and the blockers are out of the way. So what do we actually do? Here is an example of POC, simple POC workflow, and I'll try to talk you through it so that you know what it looks like. So first of all, we get a bunch of documents. It's like, let's say, a real accounting@ignascompany.com email inbox would. We don't necessarily know what's inside. It could be a lot, it could be not a lot. Most of them hopefully would be relevant. Maybe some of them will not. That doesn't matter. The first processing step we do is OCR scan, which stands for optical character recognition. This is a computer vision job. This is not GenAI. And there are already tools that do this reasonably well out of the box. You can see an example here on the right-hand side, how that could look like. So here we're looking at one-pager delivery note written in German. It has maybe 50 fields of some information, and maybe 15 to 20 of those are somehow highlighted in some colors. The file seems to be a scan, means not generated by computer, but that's okay. Once we get the files processed with OCR, next step we need to classify some documents using AI skills into relevant and not relevant, and from the relevance we have to cherry pick, let's say, what they are. Now, this is where GenAI can speed you up a lot. So AI skills are domain-specific large language models that are often created in-house and not necessarily available on open marketplaces. There are some skills published in the main cloud platforms, like, for example, extracting information from driver's licenses, US tax form processors. However, that's not quite it. For Procure-to-Pay, today you can find skills to process expense receipts, but that's, let's say, rarely works for Europe, for example, where we have multiple fiscal setups. Attached here on the right-hand side, you can see some examples of AI skill libraries that are behind paywalls, which is where they should be. There are quite a lot, and they are super powerful. Not all of them, but some of them are really production grade. They're excellent. So this is where the craft, the art, and science of technology comes in. And this is also where the IP lies. And these are the specific training models that are worth millions because they are just like so good and like can speed you up. There are quite a few tools available. And in the next 2 years, this section of like boutique industry-specific LLMs will be booming. However, I don't suppose this will be available for free for usage. So anytime you see something, you really have to test to understand if that is good enough for the use case that you have. Assuming we process something, of course, we have to check the results to understand the strengths and limitations of the models. Most common limitations happen where we didn't have enough training data or document quality was so poor that OCR couldn't read it. What do we do then? In those cases, we can either skip such documents or forward them to the human in the loop, or we try to get additional training data to enhance our model to be more robust, to handle, for example, additional languages that are not based on Latin alphabets. So moving forward, once happy enough with the results, we then train and publish our models. And this is a data science job. You can see some screenshots on the right of what it could look like in various tools. I believe the one bottom right is from GCP Document AI, where it kind of like tells you how to profile the model and to understand where it could be fine-tuned, or let's say like on which cases the result is looking good enough. Finally, it's not a proof of concept if the machine doesn't run itself. So we have to put the components together in an automation pipeline. A simple example could look like this. We start the processing when somebody sends me an email with some PDF attachment. Upon receiving it, we extract all the PDFs, split them into pages, and then try to classify them according to the use case, whether we need them, and if yes, is that an invoice? Is that a delivery note? Is that an order? Is that an order confirmation? Is that an order cancellation, or you name it? Below, you see also a simple low-code pipeline following the full Procure-to-Pay process, where we check for 6 document types. And then based on document types, we extract the specific information that we need. And then we just write it to some database. Important to notice is in most of the cases, what we're extracting could be 5 to maybe 15% of all the data that's available. So the approach, let's just extract everything and take it from there, doesn't really make sense in a lot of use cases. Because as I mentioned, if I'm a logistics person, I only care about this. Or let's say if my use case is I'm an accountant and I say, for me to issue an invoice, I need to have a signed delivery note with a normal signature. So I don't care which one, it's okay if it's missing a few IDs or product price has changed in the meanwhile. But if I have a signature, then the next best action to send out the invoice and to charge a client. That could be an example. What else? We can add some business logic on top where it makes sense to check that we are not processing the same documents twice or 3 times, or notify some teams where the manual intervention would be required. For example, if we get an invoice from the client that has a client ID that we can't find in our client database, it could be classic case of fraud that would require further investigation. So that would be something that could be then handled by alerts and reverted to the to the teams that need to take care of that. So for POC, such pipeline, simple pipeline would be fully sufficient. For pilot, however, we would have to make it more robust. For example, accept the input via API, connect to Slack, Salesforce, Jira, SAP, ERP systems, and so on. Now for the future, once the POC is done and we go to scaling it in a real factory pilot, what is success become a few different things. So while in POC we show that, look, technology works, in pilot we show that technology works reliably, meaning system has to be stable, usability needs to be scalable, which involves user training, the operation has to be production grade, and there would be quite a few more performance SLAs that would have to be signed because it would be affecting wider operations. So last question about ROI. So what I have seen in the past, that let's say like rolling out GenAI skills in Procure-to-Pay usually can give you ROI of 5 to 8x the investment, depending, of course, on the use case, on what's available, on the timelines, system stability, and of course, the complexity. So that concludes my talk for today. I hope that the session gave you some ideas on how to approach the topic and also what to expect. We might now have time for 1 to 2 questions, and if you'd like to chat in more detail, it's best if we connect on LinkedIn. Write me there. Thank you, and wish you a great day ahead.
Thank you for that wonderful presentation, Ignas. We have time for a question or two. Feel free to ask in the chat. I, for one, am delightfully surprised that the use case is so isolated within these immediate use cases. The translation, the taking OCRS. What is the technology?
Yes.
Scanning documents, taking out the relevant bits, and then having that be compared and translated against what already exists in the system. Incredibly valuable, and everything is riddled with paper. So that's a great way to digitize operations and support localized knowledge.
Yes, that is true. I was also surprised to see like such an extent of paper still around coming from different industries. But let's say like that's also a massive ROI saving opportunity. Oh, and like one more thing I didn't mention, let's say like, what are usually the goals of these like, let's say Gen AI driven transformations. So by far, the most common goal I have seen is, let's say like increasing the processing time. So it's not about replacing people with technology and let's say like reducing headcount. It's mostly about automating things that could be automated in a more robust way to free up your, let's say, experts so that they could then have more time to do the drill downs in these corner cases, step up to the next level of, let's say, like fraud detection, and let's say like maybe start working on other projects. So that is kind of like what usually big companies are looking to get out of it.
That summarization and the multilingual aspect is also something that is very attractive. I mean, especially in this world that we're becoming increasingly global and we're trading with all these different kinds of countries, different people. Just you speak 4 languages, So
yes, actually more than that, but let's
so
it's not that common.
Yeah, I can only imagine,
Yes, but I mean, it still happens, and I think this is where AI, let's say Gen AI, can boost the companies because, for example, in Europe, let's say like if you have support who process the documents in English and German, you're good for a big part of it. If you also add French, it is a national language in like a big part of, let's say like Africa. So depending on where from and where to your components go, you're good. But if you get a few suppliers with documents in, let's say like in Korean, and you don't have people in house to validate and to understand it, if you just see the numbers, let's say like in Roman, but like all the descriptions are in like non-Latin characters, you have no idea which ID numbers to take and let's say like what to do with that. And so this is where lots of companies lose a lot of time because to handle those exceptions is difficult, and it's not practical to hire a person for every language that you might get.
Well, thank you very much, Ignas. Please reach out to Ignas if you are interested in talking further about his findings and lessons learned. With that, we're going to take a short break, and then we're going to get ready for the next presentation.
Cool. Thanks, guys. I hope you liked it and enjoy the day ahead. And let's stay in touch. Bye-bye.